Welcome to ASUCERT. Today we will be discussing practice exam questions for Microsoft Certified Azure Administrator Associate Certification Exam. Question 1. You have an Azure subscription that contains a virtual network named VNet1. VNet1 contains 4 subnets named Gateway, Perimeter, NVA, and Production. The NVA subnet contains 2 Network Virtual Appliances, NVAs, that will perform network traffic inspection between the Perimeter subnet and the Production subnet. You need to implement an Azure Load Balancer for the NVAs. The solution must meet the following requirements. The NVAs must run in an active-active configuration that uses automatic failover. The load balancer must load balance traffic to 2 services on the Production subnet. The services have different IP addresses. Which 3 actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Deploy a basic load balancer. B. Deploy a standard load balancer. C. Add 2 load balancing rules that have HA ports and floating IP enabled. D. Add 2 load balancing rules that have HA ports enabled and floating IP disabled. E. Add a front-end IP configuration, a back-end pool, and a health probe. F. Add a front-end IP configuration, 2 back-end pools, and a health probe. Alright, let's break down this Azure Load Balancer question. We're dealing with a scenario where we need to load balance network traffic between 2 NVAs, or Network Virtual Appliances, for inspection between our Perimeter and Production subnets. And we've got some specific requirements: active-active configuration, automatic failover, and load balancing to 2 different services on the Production subnet. So, the correct answers here are B, C, and F. Let's dive into why. First, option B, deploy a standard load balancer. Now this is crucial. Why? Because we need to use HA ports, and HA ports are only supported by the standard load balancer. The basic load balancer simply won't cut it for this scenario. Think of the standard load balancer as the more advanced, feature-rich version. Next, option C, add 2 load balancing rules that have HA ports enabled and floating IP enabled. HA ports, or high availability ports, allow us to load balance all ports simultaneously. This is essential for our NVAs, as they need to inspect all traffic. And the floating IP? That's what enables the active-active configuration and automatic failover. When one NVA goes down, the floating IP seamlessly moves to the other, ensuring minimal disruption. It's like a quick switch, keeping your traffic flowing. Finally, option F. Add a front-end IP configuration, 2 back-end pools, and a health probe. We need a front-end IP configuration, of course, to receive the incoming traffic. But here's the key. We need 2 back-end pools. Why? Because we're load balancing to 2 different services on the Production subnet, each with its own IP address. Each service needs its own back-end pool. And of course, a health probe is vital to check the health of our NVAs and ensure traffic is only routed to healthy instances. So, to recap, standard load balancer for HA ports with floating IP for active-active failover, and 2 back-end pools for the 2 services. Question 2. You have an Azure subscription named Subscription 1 that contains 2 Azure virtual networks named VNet1 and VNet2. VNet1 contains a VPN gateway named VPN-GW1 that uses static routing. There is a site-to-site VPN connection between your on-premises network and VNet1. On a computer named Client 1 that runs Windows 10, you configure a point-to-site VPN connection to VNet1. You configure virtual network peering between VNet1 and VNet2. You verify that you can connect to VNet2 from the on-premises network. Client 1 is unable to connect to VNet2. You need to ensure that you can connect Client 1 to VNet2. What should you do? A. Select Use the Remote Virtual Networks Gateway or Route Server on VNet 1 to VNet 2 peering. B. Select Use the Remote Virtual Networks Gateway or Route Server on VNet 2 to VNet 1 peering. C. Download and reinstall the VPN Client Configuration Package on Client 1. D. Enable BGP on VPN GW1. The correct answer here is C. Let's break it down. The key here is understanding how point-to-site VPNs work with network changes. When you establish a point-to-site connection, your client downloads a configuration package that contains the routing information needed to connect to the virtual network. However, when you make changes to the network topology, like adding virtual network peering, that existing configuration package on Client 1 doesn't automatically update. This is where the Microsoft documentation comes in, and I've included a link in the description. It clearly states that if you make changes to your network topology and you're using Windows VPN clients, you must download and reinstall the VPN Client Configuration Package. This ensures the client gets the updated routing information, including the routes to VNet 2 via the peering. Think of it like this. The original configuration package is like an old map. It only shows the roads that existed when it was created. When you build new roads, the peering, the old map is useless. You need a new map, the updated configuration package, to find your way. So, downloading and reinstalling the VPN Client Configuration Package is the only way to get Client 1 to recognize and connect to VNet 2. Options A and B, concerning gateway transit, are not applicable in this point-to-site scenario. Gateway transit is used to share a gateway between peered networks, but doesn't solve the issue of a client configuration that is out of date. Option D, enabling BGP, is for dynamic routing within the site-to-site VPN, and also doesn't solve the issue of a point-to-site client having outdated routing information. Remember, when you change the network topology and you are using point-to-site VPN with Windows clients, always re-download and reinstall the client configuration package. Question 3. You have 3 offices and an Azure subscription that contains an Azure Active Directory, Azure AD tenant. You need to grant user management permissions to a local administrator in each office. What should you use? A. Azure AD roles. B. Administrative units. C. Access packages in Azure. AD entitlement management. D. Azure roles. All right, let's talk about delegating user management in Azure Active Directory. We've got 3 offices and we need to give local admins the power to manage their own users without giving them the keys to the entire kingdom. What's the best way to do this? The answer here is B, administrative units. Now, why are administrative units the perfect fit? Let's break it down. Imagine you have a big organization and you want to give each department or office a little bit of control over their own users. That's exactly what administrative units do. They allow you to create logical groupings of users, groups, and devices within Azure AD. Then you can delegate specific administrative permissions to those units. In our scenario, we'd create an administrative unit for each office. We'd then assign the local administrator for each office to their respective administrative unit, granting them the necessary user management permissions only within that unit. This means they can manage their local users without affecting users in other offices or the entire Azure AD tenant. Think of it like this. Administrative units are like smaller, self-contained departments within your larger Azure AD organization. Each department has its own manager, the local admin, who can manage their own team, the users in their unit. Let's quickly look at why the other options aren't the best fit. A. Azure AD roles. Azure AD roles are great for assigning broad permissions across the entire tenant. They're not designed for the granular, localized control we need in this scenario. C. Access packages in Azure AD entitlement management. Access packages are used for granting access to applications and resources, not for delegating user management permissions. D. Azure roles. Azure roles are for managing Azure resources, like virtual machines and storage accounts, not for user management within Azure AD. For a full list of practice questions, drop an email at acert6@gmail.com. Thanks for watching.